Good morning, this is Miss Parks, and today we're going to be solving radical equations. This is inequalities. We're not really going to be doing inequalities, but they are radical equations and rational exponent equations as well, which go together. So the first thing when we're doing all these is we definitely want to isolate the radical on one side, okay? If necessary, if it's not already done for you, then we're going to get rid of the radical by raising each side of the equation to the same exponent, so that we can get rid of the radical, and then we'll solve and we'll check our answers if necessary, okay? So here we go. So for the first one, we're going to get the radical by itself. So we're going to divide both sides by 2. That's going to give me the square root of x plus 1 is equal to 2. Now, we cannot do anything to this radical right here. The only way to get rid of it is you're basically saying the square root of what is equal to 2. You might be able to already solve that on your own. Obviously, you should know that the square root of 4 is equal to 2. And so therefore that x has to be a 3. In order to get rid of an x square or a square root, we're going to do the opposite of square rooting, which is squaring. So square root and a square are opposites, so they cancel each other out. And that equals 4, which we already talked about. We're going to subtract 1 from both sides, so x is equal to 3. Now to check your answer, you can just put 3 here and then do the work. So it would be 2 times the square root of 4 equals 4. And yeah, it works out. So you don't have to show the work. You can do the work in your head to check that answer. All right. Next, we're going to get the radical by itself. So we're going to add 1 to both sides. So we have the cube root of 2x minus 9 is equal to 3. Now, I know the cube root of 27 is equal to 3, so that's pretty good to know that the inside of this has to be 27 in order to do the actual math here. The easiest way to do this is to undo the cube root by cubing both sides. So then this cancels with that. So you get 2x minus 9 is equal to 27, just like we talked about. You're going to add 9. And 2x equals 36, and x is equal to 18. Now, if you double check that answer and you put an 18 in for x here, then that would give you the cube root of 36 minus 9, minus 1 equals 2, which is the cube root of 27 minus 1. And that works. So you can check those answers. And again, you can check that in your head. More often than not, you should be checking the ones where you have to square both sides. Those are the ones that tend to have extraneous solutions. When you cube something, unless you make like a mathematical mistake, usually those come out fine. Go ahead and try example 1 on your own. So pause the video, try those, and then come back and check your answers. Actually, if you would like, or not if you would like, but please go ahead and do all 5 of these. And then check your answers when you're finished by playing the video. All right, I'm going to divide both sides by 2. You don't have to show that step. Make sure equal sign stays kind of where it is. Then we're going to square both sides. And then we'll subtract 2. If I check that in the original problem, and I put a 14 here, then you can see that it's going to be 2 times the square root of 16, and then that equals 8. All right, next we're going to add 2 to both sides to start. So 2x minus 5 is equal to 5. Then we'll cube both sides. So 2x minus 5 is equal to 125. We'll add 5. 2x equals 130, and then divide by 2. And again, if you check that, 65 in here, that makes it 130. 130 minus 5 is 125. The cube root of 125 is 5. 5 minus 2 is 3. All right. For the next one, add 9. So the cube root of x, if you add 9 to this side, you're going to get 3. Okay. Now, if you need to show the plus 9, then go ahead and show it, but write it on both sides, please, not just on one side. And if you're not going to show it, that's fine. Just show the result of it. Okay, so just show this step. And then you're going to cube both sides. So x is equal to 27. For this one, we're going to square both sides. Again, the square root of 4 is 2, so you should know that this in here has to equal 4. That means that x has to be negative 21. Okay, it has to be in order to make that a 4. To square this, you're going to get x plus 25 equals 4. And then subtract 25. For number 3, you're going to divide both sides by 2. So the cube root of, and make sure that when you write this that it goes over everything. Then you are going to cube both sides. So you're going to get x minus 3 is equal to 4. So x is equal to 7. So that's, you're going to divide both sides by 2. So you're going to get the cube root of x minus 3 is equal to 2. Then you have to cube both sides. So x minus 3 is equal to 8. And then you're going to add 3 to both sides. So x is equal to 11. All right, so we're going to skip example 2 for now. For the next section, the most important thing is that you need to isolate one radical. Sometimes there'll be 2 and you need to isolate 1. So raising each side of an equation to the same exponent may introduce solutions that are not solutions. Like taking a negative 2 and then when you square it, it becomes a positive 4. So sometimes answers get introduced that aren't really solutions to the original equation. So these solutions are called extraneous. And I'm going to show you how to check those after we do some of these problems. So when you use this procedure, you should always check each apparent solution in the original equation. All right. So before we start this, I want to do a small little reminder of multiplying binomials or actually squaring binomials. So if you have a plus b squared, it's going to equal a squared plus 2ab plus b squared. So when you have a binomial that is squared, your result, your answer is going to be a trinomial. So it's not going to equal, so if I take x plus 3 and square it, it does not equal x squared plus 9. Okay, it does not. So that's the biggest mistake people do, is that they just square the x, they square the 3, and then they give 2 numbers. So if I take x plus 3 and I square it, that's going to give me x squared plus 6x plus 9. The middle term is 2ab. So it's 2 times these two multiplied together. So when you multiply 3 times x, it's 3x. And then if you double it, you get 6x in the middle. So let's try a few of these because I think you'll catch on once you see a few more examples. So if I do x plus 7 squared, that's going to give me x squared at the beginning, 49 at the end, and then the middle term will be these two multiplied together, so 7x, and then you double it, so 14x. All right, let's do another one. So let's do x minus 5 squared. If I do x minus 5 squared, I'm going to do x squared, then you multiply these two together, that gives you negative 5x, you double it. The last term is always positive because basically you're squaring the first and last term. Okay, so you get to square this one and this one. And then the middle one is these two multiplied together and doubled. Okay, now we could multiply that out the long way, like x minus 5 times x minus 5. So it would be x squared minus 5x minus 5x plus 25. And then you get x squared minus 10x plus 25. But the whole point is that if the pattern is always exactly the same, and if the pattern is always exactly the same, then you might as well use the pattern, which is, or the formula, a squared plus 2ab plus b squared. Okay, let me give you one more. You do this one on your own, and then check to see if you get the right answer. Okay, so x minus 8 squared. Write down what you think the answer is. All right, hopefully you got x squared minus 16x plus 64. Okay, the middle sign is always determined by the middle sign here, and the first and last term are always positive. All right, so with this in mind, let's go ahead and do these problems. All right, so we have to isolate one radical, which we did. So now we're going to square both sides. Remember, when we square this binomial, it's going to be a trinomial. So x squared plus 2x plus 1. When we square this radical, then we're just going to get what's inside the radical. Now, because we have an x squared equation, we have to set this equal to 0. So we have to subtract 7x, and we have to subtract 15. Make sure to leave the equal sign wherever the equal sign is. So x squared minus 5x minus 14 is equal to 0. And now we can factor this. Because we have a 1x squared, we can factor this in one step. Don't forget you still have an equals 0. So we're looking for the factors of negative 14. They give you negative 5. So the numbers that multiply to negative 14, that's minus 7, x plus 2. Then we set these both equal to 0. So x minus 7 equals 0. So x is equal to 7. And x plus 2 is equal to 0. Let me go ahead and do it the long way here. So we set them both equal to 0 for this time, because it's been a little bit before we've done these. All right, so those are our two answers, but we need to check those answers in the original before we did any work to the original. So we're going to check x equals 7, and we're going to check x equals negative 2 in this original equation up here before we did any work to it. So if I plugged in a 7 to both of these, this is what we would get. We would get 7 plus 1, and then would equal 7 times 7, so 49 plus 15, so we would get 8 equals the square root of 64, so 8 equals 8, fine. That's an answer. If we plugged in x equals negative 2 into this equation, so we would get negative 2 plus 1, so that would be negative 1 equals, and then here we would get 7 times negative 2, so that's negative 14 plus 15, so negative 1 equals the square root of 1, negative 1 equals 1. So that's a no, that's a yes. So this is called an extraneous root, which means that it's an apparent root. It looks like it's an answer, and it's an extraneous solution because it looks like it's an answer, but it is not, okay? So the only answer to this question is x is equal to 7. If you were doing this on a test, in the answer key, you would write x is equal to 7, okay? You wouldn't write x is equal to negative 2 and then put no next to it. You would only write x is equal to 7. All right, try the next problem, please. Pause the video and then try it. All right, let's see if you got this right. So I'm going to square 2x plus 7, x squared minus 8x plus 16. Remember, this is going to be a trinomial. Set your equation equal to 0. It's okay that the 0 is first. Don't freak out about that. You need to be comfortable leaving the variables wherever they go, okay? So x minus 9 and x minus 1. Don't forget, it's the numbers that multiply to 9 that add up to negative 10. So x equals 9, x equals 1, check. Okay, so I'm going to try x is equal to 9 in the original equation. So that's going to be 18 plus 7 is equal to 9 minus 4. So the square root of 25 is equal to 5. 9 is fine. And then I'm going to check x is equal to 1. So the square root of 2 plus 7 equals 1 minus 4. The square root of 9 is equal to negative 3. No. So the only answer that I have is 9. Now, I don't want you to think that just because 9 is an answer that the other one is definitely not going to be an answer. Sometimes they're both answers, and sometimes neither of them work, and that means they're both extraneous, which means you would have no solution. So you got to be careful. Sometimes they both work, and sometimes only one of them works. All right, so this is a second type of equation. As you can see, for example 4, there's going to be a radical on both sides of the equal sign, and when that happens, the work is a little bit more difficult, okay? So we're going to have to square both sides more than once. So we have to still isolate one of the radicals, which we are, okay? Now, on this side, it's easy. It's 3 minus x. They cancel, okay? On this side, we still have to do square this one, square this one, and then we have to multiply these two together and double it. So we're multiplying 1 times the square root of x plus 2, and then we have to double that. So then we have 2 square roots of x plus 2. So plus 2 square roots of x plus 2. Okay, so again, this is the square root of x plus 2 plus 1 squared. You square the first term, that's a squared. You square the last term, and then the middle term are these two multiplied together times 2. Okay, now we have to get this radical by itself. And because we have to get the radical by itself, we need to move everything to the other side. So we have to subtract x, we have to subtract 2, we have to subtract 1. Okay, leave this alone. All right, so when we do that, we've done the same thing to both sides. So these cancel, that cancels. So I have 2 square roots of x plus 2 is equal to 3 minus 3. So those numbers are gone. And then negative x minus x, that's negative 2x. So now I have to still get that radical isolated. So I'm going to divide both sides by 2. I still have the square root of x plus 2, sorry. And then that gives me negative x. And then I'm going to go up here. So I'm going to square both sides of this. So that's going to give me x plus 2 is equal to x squared. And then I'm going to subtract x and subtract 2 because I want to make that equal to 0. So 0 equals x squared minus x minus 2. You don't want to subtract the x squared because when you factor, you want the x squared to be positive. So now we have the factors of negative 2. That give me negative 1. Okay, and so I get x is equal to 2 and x is equal to negative 1, and I need to check them both in the original. Okay, so let's look at what the original problem is without all this mess that I put on there. Okay, so the original problem would be the square root of x plus 2, so 2 plus 2 plus 1 equals the square root of 3 minus x. Okay, so the square root of 4 plus 1 equals the square root of 1. So 2 plus 1 equals 1. 3 equals 1, no. Okay, then we try negative 1. So the square root of negative 1 plus 2 plus 1 equals the square root of 3 minus negative 1. So that's 1 plus 1 is equal to the square root of 4. So 1 plus 1 equals 2, yes. So this is my answer. The other answer is extraneous. Now the hardest part is definitely squaring this at the beginning. And we'll go over that a little bit more. Try this one and see how you do. I can give you some extra examples, but basically it's going to be this times this number times 2. So if that number is a 1, then you're going to double it, so it'll be a 2. If this number was a 2, you would double it, and that would be a 4. Okay, the inside of this stays the same. If this was a 3, then this would be a 6 radical, 6 in the middle. Move that. Here we go. So we're going to square this and this. So the first side, we take this part, square it. We take the 1 and square it. And then we multiply these two together and double it, and that's what's going to go in the middle. So that's going to be plus 2 radical x plus 6. Okay, so we multiply them together and double it. Okay, On the right side, we're just going to get 7 minus x because this cancels with that. All right, now we need to get that stuff in the middle isolated. So subtract x, subtract 6, subtract 1. This gives me 2 radical x plus 6 is equal to 7 minus 7. That goes away, so negative 2x. Now, the reason I divide here by 2 is because 2 goes into this evenly. If it didn't go in evenly, I would not divide by 2. I would just square right here, okay? So I'm going to divide both sides by 2. And then I'm going to go up here. And that's going to give me x plus 6. The square root of x plus 6 is equal to negative x. Then I'll square both sides again. So I'm going to get x plus 6 is equal to x squared. Then 0 equals x squared minus x minus 6. I'm going to move both of those over. So 0 is equal to x minus 3 and x plus 2. So x is equal to 3, x is equal to negative 2. So in the original equation, I need to try these. So in the original equation up here, if I try x is equal to 3, I'm going to get 3 plus 6 plus 1 is equal to the square root of 7 minus 3. So the square root of 9 plus 1 is equal to the square root of 4. So 3 plus 1 is equal to 2. No. So 3 doesn't work. Then I'm going to go ahead and try negative 2. So the square root of negative 2 plus 6 plus 1 is equal to the square root of 7 minus negative 2. So the square root of 4 plus 1 is equal to the square root of 9. 2 plus 1 equals 3. Yes. So negative 2 is the correct equation. All right. I know it's a lot, and I might just be doing this part for the honors class, but it's good to know this. All right, go ahead and try the next 3 problems, please. All right, so the first one, you should have already done all 3 of them. And if you haven't, pause the video, do all 3 of them, and then come back and check. All right. 10x plus 9 is equal to x squared plus 6x plus 9. Don't forget you need a trinomial here. Subtract 10x. Subtract 9. So I have 0 equals x squared minus 4x. So that means that I can have to factor this by factoring out the greatest common factor, x times x minus 4. And then 0 equals x times x minus 4. That means you have to set each of them equal to 0. So x equals 0, x minus 4 equals 0, x equals 4. And then we need to check them. So if I check x equals 0, then I get the square root of, if I put a 0 here, then I get the square root of 9 is equal to 0 plus 3. And so that works. And if I check 4 in the original equation, then I get the square root of 49 is equal to 4 plus 3. So 7 equals 7. They both work. So I get x is equal to 0, x is equal to 4, and there are no extraneous roots in this one, no extraneous solutions. Both answers work. For the next one, if you square both sides, you get 2x plus 5 is equal to x plus 7. So then in this case, we don't have to set it equal to 0 because there's no x squared. So subtract x, subtract 5. So you get x on this side and you get 2 on that side. And x equals 2 is your answer. If you plug in a 2, this is 4 plus 5. That's 2 plus 7. Square root of 9 equals the square root of 9. All right. A lot of times people get to this problem and they get stuck here and they start trying to make it equal to 0. You don't need to do that unless you have an x squared. All right, for this one, we're going to square both sides. So again, you square the first term, you square the last term, And then the middle term is these two multiplied together and then doubled. So that's going to give you negative 4 square root of x plus 6. Okay, negative 4 square root of x plus 6. Because you're going to, when you multiply those together, basically the negative 2 just goes in front. And then when you double it, it just becomes negative 4. And now we need to isolate that part. So we leave this alone on this side. It gets squared. And now we're going to subtract x. We're going to subtract 6. And we're going to subtract 4. We don't subtract this 4 because it's multiplied by this. So we leave that alone. So on this side, these all cancel out. So I just get negative 4 square root of x plus 6. And on this side, x minus x cancels. So I get negative 2, negative 6, negative 4. That's negative 12. Then I just divide both sides by negative 4. And that's going to give me x plus 6. The square root of x plus 6 is equal to 3. You should know that the square root of 9 is equal to 3. That means x has to be 3. So x plus 6 is equal to 9. X is equal to 3. If we check that in the original equation, then we get 3 plus 6 minus 2 equals the square root of 3 minus 2. 9 square root of 1. 3 minus 2 equals 1. Yeah. So x is equal to 3 is the correct answer. And I know this is a long section. We'll probably split it up into 3 different parts when we do this in class. But that's it for that example. And we'll do example 5 in a little bit. All right, let's go ahead and go on to example 5. And this in example 6, they're very similar to each other. So these are like radicals because if you remember something to a rational exponent, that 2x to the 3/4 really means the 4th root of 2x to the 3rd. So I'm going to explain how to do these. Instead of isolating the radical, we are going to isolate the power. Okay, and then we will raise each side to the reciprocal power. Okay, so we're going to, that 3/4 applies to the entire thing. Okay, now if this looked like this, which actually I might do that just so that you can see the difference. If it looked like this, the problem would be done differently. And I'm going to show you both of those so that you can see that. So for the first one, we're going to go ahead and subtract 2. So I'm going to have 2x to the 3/4 is equal to 8. And then since this 3/4 applies to all of that, in order to get rid of it, I'm going to raise each side. Actually, I'm just going to go ahead and put this here. Raise each side to the 4/3 power. And really, it's a big old parentheses there. So raise this side to the 4/3. These cancel. When you multiply 4/3 and 3/4, anytime you multiply reciprocals together, they cancel each other out and become 1. So now I have 2x is equal to, and on this side, this means the cube root of 8 to the 4th, which is 2 to the 4th, which is 16. And if I divide both sides by 2, I get x is equal to 8. Now, if I were doing it in this point, I would subtract 2 from both sides. Then I would divide by 2. And then I would raise each side to the 4/3 power. So these would cancel, and I would get x is equal to 4 to the 4/3, which you would have to put into your calculator. And so if you put that into your calculator, it would be 4 raised up to the 4/3 power. You would get like 6.34 or 6.35 actually. Okay, I just want you to know that the parentheses make a big difference because here the 3/4 applies to the whole thing, and here the 3/4 only applies to the x. Okay. All right, and the reason that I didn't do this the same way I did that is because there is no cube root of 4 So you can't take the cube root of 4. It's not a whole number, so you have to use a decimal there. All right, go ahead and try this example, please. Go ahead and pause the video. All right, so we have 3x to the 3/4 is equal to 27. I'm going to raise each side to the 4/3 power. You're raising it up to the 4/3. You're not multiplying by 4/3. Just be clear. The two exponents get multiplied together, and they give you 1. And then on this side, I get the cube root of 27 to the 4th, which is 3 to the 4th, which is 81. And then divide both sides by 3 here. So x is equal to 27 on this one. All right, for the next one, the exponent applies to this whole thing. So I'm going to raise each side to the reciprocal of 1/2, which is 2, or 2 over 1. So that gives me x plus 30 is equal to x squared. So now I have to set this equal to 0. Subtract the x, subtract the 30 over to the other side because you want your x squared to be positive. And this will be x minus 6 and x plus 5. X equals 6, x equals -5. If you check these in the original, then this would give you the 6. If you put this in here, you would have 36 to the 1/2 equals 6, which is the square root of 36. So that works. And then if you put -5 in there, you would have 25 to the 1/2 is equal to -5. 5 equals -5, no. So that one would be extraneous. Okay, and again, you have to try them in the original problem before you squared both sides. Go ahead and do all the rest of these and see how you do. All right, so we're going to square both sides because that's the reciprocal of that. X plus 12 is equal to x squared. So set that equal to 0. The only reason we get to factor this in one step is because that's a 1x squared. All right, so checking these, the first one, 4 plus, put in a 4 here, and a 4 here. That's 16 to the 1/2, I should write. Right, so if we put a 4 here and a 4 here, then the square root of 16 is 4. And then if I put a -3 here, then you would get 9 to the 1/2 equals -3. 3 equals -3. So no. All right, the last 3. I'm going to raise each side to the 3rd power. So 3x is equal to -27. And x equals -9. And if you want to check, -9 in here makes that -27. The cube root of -27 is -3, and that's fine. Again, you only have to check really when you square both sides because cubing something doesn't really affect anything. Like here, we're going to square both sides. You definitely have to check on this kind. Okay, so when the exponent that you're raising is even, you should check both answers. So I'm going to get x plus 6 is equal to x squared. You have to set it equal to 0 anytime you have an x squared. Okay, so x minus 3, x plus 2, x equals 3, x equals -2. And again, if you plug those numbers in, if I plug in a 3 here and a 3 here, then I get 9 to the 1/2 equals 3. And if I plug in a -2 here, then I would get 4 to the 1/2 equals -2. So this is yes, this is no. And that's it for that one. And then for the last one, we're going to raise each side to the 4/3. So the top number is even, which means we do need to check our answers on this one. So x plus 2 is equal to the cube root of 8 to the 4th, which is 2 to the 4th, so that's 16. So x equals 14. Now, if I check that in the original equation, so then I get 16 to the 3/4 is equal to 8. So the 4th root, well, you can just put that in your calculator, but it's the 4th root of 16 to the 3rd, which is 2 to the 3rd, which is 8. So that works out. All right, so I know I went a little bit fast on the end of that. I'm hoping that you had a chance to watch that kind of at your own pace and pause the video when you needed to.